Work it, make it, do it, make sense.
Good morning, everybody. Oh, that was just abysmal, terrible. Good morning. Thank you very much. Very good. Welcome, everybody. I appreciate it. Come on in. I expect we're going to have a few stragglers, but such is life. We're going to go through a lot of stuff. Actually, I should contextualize this. I should say we're going to go through a lot of stuff specific to one thing, right? This year, normally when I do other talks, I tend to do these roving sort of tours of whole ecosystems. And this time I just wanted to spend a little time deep diving on one particular topic. In particular, we're going to look at some of the support in sort of Spring 5 coming up and the ecosystem at large for reactive programming. So keep that in mind. And if you have questions, comments, feedback, whatever, I'm happy to answer your questions. I'm here for you. I'm on the internet. The code, by the way, is on GitHub at those coordinates. Welcome, everybody. Thank you for coming. It's on GitHub at those coordinates, so please don't hesitate to grab that and follow along at home later on. I'm on the internet, as I say. If you have questions, comments, feedback, whatever, I'm very happy to hear from you. So show of hands, how many of you are on Twitter? Twitter, right on. Good stuff. I ask every year, and that level goes up progressively, and that is encouraging. That makes me feel like we're in a good place. And for the rest of you, get on it. It's the new IRC. It's a great place to be. If you're a developer using software, open source software in particular, today in this day and age, then you owe it to yourself to engage with the people that drive that software, right, that drive that code. So they're there. They're here for you, as I am as well. What about email? Email. Anybody? Is anybody using email? No. Okay, well, if you're there, I'm also happy to answer questions. I'm happy to engage, so don't hesitate to reach out to me. A little bit about me. I just want to, establish the hopefully obvious. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I have been for the last going on 8 years now. And I've also been an open source contributor and engineer in the different projects for many years. I work on lots of different Spring projects. I've talked about this loudly and proudly many times. I am, and this is, you can check GitHub. You can see this for a fact. I am the #1, top ranked, most prolific, most visible, most highly rated contributor of bugs, but still #1. #1 in all of the projects to which I commit. More bugs per commit than any other engineer on the projects like Spring Boot, Spring Cloud, Spring Integration, Spring Batch, Vaadin, Time Leaf Activity, etc. I didn't fix them. I created them. But it was an accident, right? Mostly, I'm sure. So there's that. I work in the open source world. I also do my best to help people engage in the ecosystem, to help them build better software, often in terms of the Java platform and in terms of Spring. And as part of that, I've done training videos. So I just finished the second edition of my Building Microservices with Spring Boot live lessons with my friend, the one, the only, the amazing, the inimitable Spring Boot co-founder Phil Webb. And I'm working on my book. Finally, it's so close. You have no idea. I've been talking about that book for what is it now? 3 years, 2 years. So it's here almost. That book is called Cloud Native Java. It's all about how to build applications that survive and thrive on the cloud or in the cloud. And for those of you who are wondering, and I can see it in your eyes, I can see it welling in your eyes, that curiosity, that latent curiosity, that bird on the cover is a blue-eared kingfisher. It's a bird that is indigenous, or as we say in English, native to Java, the Indonesian Java Islands. It's a bird. And birds fly, often through the clouds. So it's a bird that's native to Java that flies in the clouds. It's a cloud-native Java bird. It's a bird. Never mind. It'll come. Give it time. Give it time. So there's that, right? And I work at Pivotal. How many of you know Pivotal? Just curious, open show of hands. Good stuff, hot sauce. So we have a lot of great open source software at Pivotal. We care very much about open source. But let's be very clear. It is not the reason we are here. It's not the reason that we wake up every morning and spring out of bed. What we care about is helping people deliver software faster and safer to production. And we see that a lot of organizations want to go faster. They need to go faster. They know they need to go faster, but they struggle. And so a recent trend in the last, say, 5, maybe 10 years or so since the era of cloud computing and the economics of cloud computing has been to optimize for human potential, optimize for team dynamics by decomposing your large applications into what are called microservices. And when you do this, you run into a host of sort of non-functional requirements, things that you need to care about in the sort of design of each individual service and in the coordination of those services in the system. One thing, if you've seen me before, you know I've talked about Spring Boot and Spring Cloud as ways to address a lot of these sort of non-functional requirements, a lot of this sort of implicit complexity. One thing that we've seen a lot of people struggle with is, okay, I've got my services up, and they're up and running, and they're talking to each other, but I've got a large amount of data, right? Now my data is now separated, it's siloed into different services, and these things need to be sort of visible to each other. They need to talk to each other. And if you're dealing with a lot of data, that becomes expensive. Because it means in the traditional REST sort of HTTP-based approach, on the Java ecosystem at least, that you're sending a lot of data over a socket, which is being kept until the socket is done, until the input and output is done. So that becomes expensive. And so we're looking for ways to go faster. We're looking for ways to sort of reduce the cost of that input and output at large scale. Now, this is where reactive programming comes in. This is where the need for reactive programming comes in. And we are by no means the first, right? In the Java ecosystem since Java 1.4, there's been in the channel, in Java NIO and the support for channels, there's been support for asynchronous I.O. This I.O. That now delegates all the way down to the kernel, to the lowest levels in the operating system, to handle the input and output. At the lowest levels of the operating systems, and most operating systems, there's this idea that I have a file descriptor, and there's input and output that's going to happen, and I want to be notified when I can read or write from that channel, from that file descriptor. That's not a new thing. That's been in operating systems for 20 plus years. In fact, by default, most input and output, especially network input and output, is asynchronous if you go to the lower levels of the operating system. It's only when you go up to the JDK where you have this illusion of a stream. And so what we're trying to do is to reclaim that sort of asynchronous, event-driven approach to input and output so as to allow us to reclaim the idle time in between actual data being available, right? I want to be able to say, okay, there's nothing happening right now. Let's do something else with a thread instead of waiting for that, instead of waiting for that response. So the goal here, in JDK 1.4 and later was to sort of make that available. But the problem is that, when you build systems on top of this low-level input and output model, you need to think about events at every other layer on top of that. Otherwise, you're going to block somewhere else. And so the ecosystem, as a whole, has done a lot of great things to sort of make this available, to make this possible, to think about interactions with services in an event-driven approach. So we have a lot of great companies out there, a lot of great technologies out there that have come about as a response to this requirement. Microsoft, of course, did the RX extensions for .NET, and that inspired the work that Netflix did on something called RX Java. There's a company called they're called Lightbend now. They're called TypeSafe when they started this. They did a lot of great work in their clustering tool called Akka, and they have good support for asynchronous I/O there as well. At Red Hat now, there's a technology called Vertex, also a very interesting sort of approach to reactivity. And actually, that started at SpringSource, right? So that's kind of a little interesting tangent. At Pivotal, we have a project called Reactor. And Reactor has been around since 2011 in some form or another. But it's only recently, in the last few years, where all these different players, and I'm sure I'm missing at least one. Who am I missing? RX Java, Lightbend, Pivotal, Netflix, got that. It's only in the last few years, anyway, that all these different players have come together and sort of realized that what we need to do is to extricate or to define from these common approaches the thing that really, really matters here, the core interop model. And that has to do with events. It has to do with this idea that I have a thing that I want to consume and work with asynchronously. And that became what's called the Reactive Streams Initiative. These different players worked to define at the very essence the very basic interaction model for something that is essentially asynchronous. So the Reactive Streams Initiative is very, very simple. It's a de facto standard. It defines 4 different types. It defines a type called publisher. A publisher produces values. Subscribers can subscribe to listen to values coming off of that publisher. When they do, they get a subscription. And there is something that can do both. There's something that can be both a subscriber and a publisher, and that's called a processor. That's it. Those are the 4 core types. It fundamentally, simplifies what we're trying to do here. It says, I've got a thing that produces values, and I want to listen for them. Right? This is not a particularly new idea. And again, if you've used any one of these different APIs, you've had that ability as well. But with that standard, with that default basic interop model, we have now something that different organizations can use to talk to each other, different technologies can use to talk to each other. Which means that you're no longer in a situation where you have part of the stack that is asynchronous and part of it that is synchronous or reactive and not reactive. So then the question is, how do I do more interesting things on top of that? I've got this really, really convenient programming model, this reactive programming model, and I want to compose. I want to, work with streams of values, and I want to transform them. I want to filter them. I want to do the kind of things you might expect to do with an unending stream of values. The operators that you might expect if you had a collection, for example, in the JDK, or a stream, a Java 8 util stream. So these operators are missing in the default sort of reactive streams initiative. And so the value that a lot of these different implementations can provide is to provide these higher level operators on top of this base sort of interop model, this base reactive streams initiative. And so then once we have that in place, that's what Reactor does, right? Reactor provides that basic, those operators. Once you have that in place, you can now integrate all that into the parts of the ecosystem that you care about. So what we're going to talk about today is Spring 5. Spring 5 is not GA yet. It'll be GA this summer, right? Very soon. And it is the basis for what we're going to do. There's actually there's the reactive support, then there's the support in the web tier. And then because we have Spring 5, the ecosystem at large, the Spring ecosystem, is also being sort of updated where appropriate to support the reactive programming model and to support what we're doing in Spring 5. So you'll see today we're going to talk about Spring Data, reactive Spring Data access. Spring Data is an umbrella project that provides integration with all sorts of different data stores and persistence technologies. We don't try and provide the illusion of reactivity where it's not possible, however, right? So some NoSQL data stores are ahead of the curve here. They've already gone the extra mile, and they've built reactive integration in their drivers, to make it easier for consumers to consume that in a reactive way. And where appropriate, we've exposed that in Spring Data. So Spring Data has great support for reactive MongoDB, reactive Cassandra, reactive Redis, Couchbase, right? But you're not going to see, for example, not for a while at least, reactive SQL. If you have SQL and you have a synchronous driver and you try and use it from a reactive ecosystem, you're going to be missing out. You're going to make life more complicated, right? If you try and use a thread pool to sort of background work being done in a synchronous JDBC call, now you've got a much more complicated programming model that doesn't actually offer the same benefits at scale. You've got something way worse than JDBC, so we don't recommend that. We're not trying to provide that if it's not appropriate, right? Okay. Now, what we're going to do is we're going to build a simple application, something that we can work with. Now, I mentioned earlier that we have the Reactor Project. The Reactor Project is our umbrella sort of integration for reactive programming. In the Reactor API, you have this basic type called a publisher. I've told you about that. And then you have 2 specializations that implement publisher. One is called a flux, F-L-U-X. A flux is a publisher that produces 0 to n values. A mono is a publisher that produces 0 or 1 values. Could I build my entire system in terms of publisher? Yes. But the specialization is interesting when you're trying to describe in your API what the client should expect. Now, functionally, all clients that get any implementation of a publisher are just going to expect to operate on the return values, 0 to n. But it's nice to know that if I call this method, I'm not going to sit here waiting for a year. I'm only expecting 1 value, right? These specializations are documentational as much as they are anything else. And so we're going to build an application today, something, I like to have hypotheticals, just very simple applications so we don't have to linger too much on the domain. So what I want to do is I want to build an application that helps us model movies, right? Imagine we had some sort of highly scalable system for streaming movies over the internet, novel though that is. Some sort of network access to watch flicks. some kind of thing. Maybe we could call it Netflix. I don't know. We've got to do something. So I'm going to build a new application here today at start.spring.io. If you know me, then you know this is my second favorite place on the internet. My first favorite place on the internet is production. I love production. I hope you love production. You should go as early and often as possible. Bring the kids, bring the family. It's the happiest place on earth. It's better than Disneyland. I love production, and so should you. But if you're not already at production, then you begin your journey here at start.spring.io. If you want for inspiration in the early morning before your cup of tea or coffee, start.spring.io. And if your children are restless and can't sleep, start.spring.io. If you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application using Spring Boot 2.0. This is a snapshot. Spring Boot itself will ship as a GA version in December after Spring 5, right? And so by the time you get the GA versions of Spring Boot, you'll see integrated in sort of the common things that you care about, support for reactive programming, including data access, including security, including the web tier, etc. So we're going to cover just some of that today. Okay? So I'm going to build an application to manage our movies. We're going to call them movies, but we need a service to manage movies, and I was thinking we call it the FluxFlix service, which is short for FFS, which could also mean for Flux sake, right? So we're going to say FFS, and we could also use Reactive Web, Reactive Mongo. We're going to use Lombok, which is a compile time annotation processor. And I think that ought to do. We're going to hit generate, and that'll give us a new zip file. And I'm going to open this up in my IDE. And again, it doesn't really matter which IDE you use. I happen to be using IntelliJ, but this is just a Spring Boot application. And so all you need is ideally Java 8 and Maven or Gradle. And I'm using Maven. Now, quick show of hands. How many of you are on Java 8? Good to know. Wow, the largest majority. How many of you are eagerly looking forward to Java 9, like I am? Right on. Good stuff. You are here in London at the forefront of technology in so many ways, so I'm very curious every time I come to this great city. So, FFS application. Here we go. I've got a new application. Can you see that in the back, my friends? Can you see the code in the back? Raise your hand if you can. Okay. Anybody can't? Can't. Somebody says can't. Okay, so font. All right. Bigger. Okay? So let's say we've got a type of entity. We're going to save this into our database. I'm using MongoDB. I'm using the reactive support for MongoDB because if you want to lose your data reactively, then MongoDB is the best choice. So I'm going to go ahead and say that I've got an entity of type movie. It's going to be stored into a document, right? I'm using Spring Data Mongo here to support that mapping. I'm going to give it a primary key or a surrogate unique ID, and I'm going to signal that this is a unique ID by using the Spring Data annotation at ID. I'm going to say that my movie has a title, right? And there we go. I might even give it I think title's fine for now, right? So I want to create getters and setters and constructors and all that, and I can certainly code generate my way to that goal, but instead I'm going to use Lombok, which is a compile time code and an annotation compile time annotation processor that will synthetically generate getters and setters and an equals method and toString and so on. So I'm also going to say that I want an all argument constructor and a no argument constructor, and that'll come with that as well. And then I'm going to save and I'm going to work with these instances of this data using a repository. So again, this should be fairly familiar if you've ever used Spring Data, right? So here I'm creating a reactive Mongo repository that manages entities of type movie whose primary key is of type string in this case, right? So the reactive Mongo repository is built in terms of sort of the reactive types that we expect from Reactor, right? So you can see I've got an insert method that returns a mono, that is to say a reactive value that contains a single value, or a flux for insert that returns multiple, right? Same thing here. I can provide a publisher as well. That means I can write asynchronously. I can write values as they become available to me to the database, right? And in the meantime, in between writes, in between activity, the I/O is going to background. It's not going to keep that thread blocked, right? I also get support for sorting and paging where appropriate, right? Now you get all this is all pretty standard fare, except that it's been reworked in terms of, or in the light of Reactor. Okay, so I've got a repository now. What I want to do is I want to save some records in the database so that we have something with which to work. So again, this is just a simple demo. Let's create some movies. Okay, let's create some movies that we can use in our application. As a demo, as a sample, okay? So in order to do this, I'm going to inject the movie repository here. This is a command line runner. It's a command line runner. It's an object that Spring will call back when the application is initialized and everything is ready for work. And what I want to do is I want to save some records into the database. So we need to create some records, some names here. So I want your help. This is audience participation time. I want to find all of the movies that we can find that work with a theme of reactivity and web flux and lambdas and so on. So I will get you started. One of my favorite examples was from my friend Phil Webb. Phil Webb he suggested silence of the lambdas, which I think is pretty awesome, right? Can anybody else think of one like that? There's one, Aeon Flux, if you know anime, yeah? What movie had the flux capacitor? Thank you. What about the fluxinator? No? Maybe? Anybody else have a few?
Lord of the Fluxes.
Yes, Lord of the Fluxes. What about in Spanish? Y tu mano también. That means monkey instead of mama, right? Okay, what about, I guess that's enough. What do you think? It's a nice simple set. 1, 2, 3, 4, 5, 6. That's fine. If you think of some, just yell it out and it's perfectly appropriate to stop everything we're doing and go back and fix that, because I would love to have more records there. So what I want to do is now I want to visit every single one of these and write it to the database. So I want to say for each of these movie titles, I want to write to the database using this repository. So I'm going to say save a new movie, and I'm going to pass in a ID and a title. Let me make the ID first, so that we can pass that in instead. So the ID, of course, because it's MongoDB, we need to provide the client-side ID. So we say uuid.random ID to string, and then we pass in the movie title, and there we are. There we are. At least that's what we think, right? If you've used MongoDB, if you've used Spring Data and MongoDB, or indeed Spring Data in most anything, at this point you'd think you'd be home free, but it won't actually execute if you run this code. Nothing's going to happen. And the reason is because it returns a mono. And that mono is an asynchronous value. You can compose these reactive types. You can compose publishers into chains. And just like the Java Stream API, you can compose them, and then the end result, the terminus at the end of the chain, has to actually invoke the whole thing. Nothing happens until you activate the chain, basically. So even though I've started the application, we need to tell this asynchronous type that we are ready to consume it, to listen to it. So we can say, I want to subscribe. And here, there are a few different instances of subscriber. There's one call that just takes a consumer of movie, which in our case is fine, right? So we can say system.out.println, passing in movie.toString with a period, hopefully. Okay. And that'll work. But I'm using MongoDB, and it doesn't do a great job of keeping my data, but it might keep all my data. In which case, this is additive, right? Every single time I restart my process, it's going to add more data to the database, isn't it? And so I'm going to have, the Fluxinator, Back to the Future, and Flux, Lord of the Fluxes, etc., multiple times. If I run it again, we'll see that reflected eventually. Well, I'm actually subscribing here, but if I were to do a find all, if I did movie repository.findall dot subscribe system out print line, right? You'd see the original 6, and then you'd see everything all dumped out again, so you'll see at least 18 at this point. Yeah, so we're getting duplicates here. So what we need to do is now, instead of just calling this one thing, we need to do a dependent call. We need to say, I want to delete everything in the database, and then insert some sample records, right? So I'm going to say delete all, subscribe, and again, here, I don't care about the return value, right? I just want to run some code at the very end of the process and then use that as an opportunity to write some data to the database. So I'm going to use this overloaded version of subscribe that takes two consumers, one for the actual value, one for a throwable, any exception that's thrown, and then finally a runnable. And this runnable is what we're going to take advantage of here. We're going to say, when everything is done, call that code. Okay? So there we are. And indeed, because it's a lambda, I could actually just it's only one expression in theory. I could get rid of that. So now let's see what happens. Okay, there we are. So, I got rid of the find all, didn't I? Suppose I could leave that. So movie repository.findall for each, or sorry, yes, .subscribe, system.out, print line. Okay. Just to make sure everything's working as we expected it to. So it printed it twice, which is what we expect, right? It's printing it once here, and it's printing it once here. So everything is as it should be. Now, we've got data into the database. We need to build a service. I want to have a service to work with. I want to build a REST API eventually, but we need a service in order to do that. So I'm going to build a Flux service, as we talked about here. And this service, our service is going to provide us and work with these reactive types, right? So I'm going to say Flux service. It's a service, a regular Spring component. And in the service, we're going to provide definitions for a few interesting sort of use cases. One is I want to find all of the records. So I'm going to say, give me a flux of every single value in the database. That's kind of interesting. I want to find just one value. So I'll say, give me a mono by ID, by string movie ID, right? And then I want to say, I want to have it give me a stream of all of the streaming, right? So imagine we are actually some sort of online network accessible movie watching system. Wouldn't it be nice to be able to log in and see the fire hose of all the people who are streaming videos? You could basically stream all the streams, right? Or cross the streams. So what I want to do is I want to have that kind of endpoint, but we don't actually have a bazillion people logged into my system at any given time streaming videos, so we don't have a live feed we can use, so we're going to just fake it until we can make it, right? So what I'm going to do is I'm going to generate a stream or a flux of events corresponding to streams, right? Stream the streams, right? And so this is for a given movie. We're going to find all the movie events. And so we don't have this type on the class path. We don't have it here. So let's define that as well. And our movie event will just contain the movie itself and the date. Maybe we could have a username and so on. But for our purposes, I think it's fine to have it just like that. And there's the data annotation, no args, all args, etc. So there we have a simple DTO, a simple POJO that we can use to model this, okay? So what we're going to do now is we're going to implement the service, and we're going to certainly use that repository because that repository gives us most of what we need for this implementation, right? We don't need to actually do all that much work. We can just pass through where appropriate. So for now, let's return null here. And for the by ID thing, we're going to say movie repository dot find by ID, passing in the movie ID. And that'll be just a pass through, right? That's fine. Same thing here. We can say movie repository dot find all, passing through. For this last one, though, what I want to do is I want to synthesize. I want to create a fake endpoint that does kind of what we want. And so how about we just say that I want to value every single second. I want to emit a new movie event every second, as though somebody's watching a movie every second. And so this gives us a chance to look at how to compose different streams to get one resulting product from two sort of factors or inputs, right? So here, I'm going to say that I want to create a stream that creates a new value every second, right? So this is a publisher that'll emit a value every second, and in the time between that, we're not keeping that open. We're not blocking, right? This is a sort of artificial kind of example, but I want to have two things to work with, so this will give us that ability. So the other thing we want is to now have a movie event that we can synthesize every time we get a new second, a new time. So we're going to say flux.generate or flux.fromStream, and I'll use the stream API. I'll use the Java 8 stream.api to generate a new movie event, passing in the movie, which we have to we have to come up with up here, right? So we have to say movie, and I'm going to pass that movie in and a time, a clock time. So movie and a new date, yeah? So this is null, of course. That's not going to work. We'll come back to that in a second. Now I've got these two fluxes, and what I really want is I want to say, take these both, zip them together. Take both of them, and take one value from the left and take one value from the right. And I won't take one more value from the right unless I have one from the left. So it's moving in lockstep. I'm zipping them up like you would two sides of a zipper, right? So interval, I'm going to take the interval value here and the event value. I'm going to flat map it. I'm going to transform it from a collection of asynchronous values of tuple, of type 2, tuple 2, to a, come on, okay, of type 2, right? There we are. So there's the result will be a flux of movie events, but we'll only get one new movie event every second because they're going to move in lockstep, right? And we're going to transform it. Now, let's create this movie. We need to get this movie, as we said, and then use that to drive this thing down here. So here, we can say movie repository. Actually, we can just say by ID, can't we? Passing in the movie ID. And then we can subscribe to that. Or even better, flat map it, right? So what I'm going to say is, for every movie, take the results and then return them. Okay, there's our service end event, or rather our asynchronous sort of zipped up stream that we can use. Now, let's go ahead and use this to build a REST API. And here too, this should look pretty familiar, right? So flux, flix, REST controller. And we're going to use the Spring at REST controller annotation. And this is, fairly straightforward. So let's see. We want the private final flux flix service. And we'll create an endpoint here. And we're going to just have 3 endpoints that map more or less to what we just did in the implementation. So we'll have one endpoint, public mono of movie. We'll say, give me the movie by its ID. And we'll turn this into an endpoint in a second here. Movie ID. Okay, return null. We want to have public flux movie all, right? Same thing as before. And we want to have a endpoint that returns a flux of movie events, right? Cross the streams, string movie ID. Now, the first two I think are fairly straightforward. They should be anyway, right? We're going to map this to movies, fair enough, okay? And we can use the flux service and just say, give me everything. And Spring Web Flux, which is the module in Spring 5 that provides the reactive programming model here, will automatically do the right thing. It'll emit output as it becomes available, but it won't block the server socket on the service that's actually writing the output if there are no values to write. It'll move that thread that's being used to serve the response back into the thread pool, and it'll keep that server socket in the background. And if there's an event that says there's more input available, it'll bring it back to life and send more results back. But in the meantime, other requests it's possible to process other requests that come in. This gives us the ability to handle more requests with the same processing power, basically, right? Per transaction, however, keep in mind, this is going to be slower than the synchronous approach. That is to say, the cost of starting a new request and then sending a response and finishing is going to be possibly more expensive if you're doing reactive programming. It's only if you have a lot of data where you want to be able to passivate in the idle gaps in the input and output that this becomes a better approach. It becomes more scalable. Now, Spring Web Flux is an altogether new API that uses Spring MVC style annotation. So if you've ever used Spring MVC, this should feel very familiar. Spring Web Flux works on traditional servlet 3.1 implementations if you want, but it's not going to be very efficient. Remember, the servlet API isn't reactive. It's an we can fake it in some places, but it's not going to work in all places. So we actually have a net new Netty-based runtime. That's what we're using right now. This isn't using Tomcat or something. This is actually a brand new web runtime that we built on top of Netty that should feel very familiar. So here's an endpoint. We're going to say we want to use this one, flux service by ID, passing in the ID, and we'll map this one as well. Say at get mapping movies movie ID, and this is just a path variable. Yeah. Okay, and then finally, we want to map this one. Now, this one doesn't lend itself to traditional REST, does it? We're going to send a lot of data back, and typical REST clients and REST processing says, okay, when the data comes in, I want to wait until the end of file, so to speak, the end of the buffer, and then process it all. I'm going to take the whole JSON document or the whole XML document and then slurp it up and then process it at one time, right? It's not natural for most REST services to just sit there waiting for responses that aren't there in a chunked style. So what we're going to use is server-sent events. We could use anything. We could use WebSockets here, right? The point is, what we want us to do is we want to send to the client output that the client expects to be asynchronous, to produce a value and then maybe not produce a value for a little while and then produce a value. So we want something that supports server-side push. We want to send data down when we can. Okay? So we're going to say produces media type dot text stream value, and here we're going to use the mapping. So flex service dot stream the streams, passing in the movie ID, and here we'll give this an annotation. Okay, let's see if that works. That should be a very trivial sort of endpoint. And if you've ever used Spring MVC and you've done something like WebSockets or you've done something like server-send events, you know that we had to do a fair bit of gymnastics to make it work in Spring MVC before, because it's a completely different input-output model. The default approach in Spring MVC proper is to use blocking servlet APIs. So you kind of have to do this sort of very obvious, very pre-planned sort of approach to doing asynchronous output. Well, here, a Flux is asynchronous. It's by default. That's what we're expecting all the time. So if you're returning a stream of values that we need to write out to the output stream, or you're returning WebSockets, or you're doing server-send events, it's just a Flux, right? Same, it's Fluxes all the way down. So let's go ahead and try that. Okay, so curl HTTP localhost 8080 / even movies. How'd we do? Not bad. Let me grab one of those IDs so we can pass this to JSON PP, which is the pretty printer. We'll grab this unique ID. Can we grab that specific reference? HTTP localhost 8080 movies. Look at that. We got that one. Good. What about the events? What did we say? We called it streams? Events. Mustn't forget that. Hey, look at that. We're generating server-send events. And by the way, server-send event is basically JSON payloads, but it's got frames, message frames. Very, very traditional sort of messaging kind of approach. So clients are expecting that the payload is there, and then after that, you've got a blank delimiter. So they know that they can stop blocking, waiting for the reply, right? Until another one comes back. So this is one approach to building a REST API in Spring WebFlux. And I like it if you're using Spring MVC before and you've done traditional Spring MVC, this will feel very natural. But there is a separate approach. There's another approach called functional reactive endpoints, and that's actually become one of my favorite approaches. So the way that works is you create a router function, and the router function expects you to describe the mapping and then the handler that processes the mapping. And it's very similar to in the Ruby on Rails, in the Ruby world, you've got Sinatra. In the Scala world, you've got Scalatra. Spark, also very similar, I think. So it's a sort of functional mapping from mapping to endpoint. Okay. So we're going to say router functions dot route. Create a request predicate get / movies, and here it's asking me to provide a new handler function, right, for this one endpoint. So this could, it's not all that hard to do that, but I want to use lambdas here. This is actually a nice opportunity to use method references, rather. So I'm going to say public static class route handlers. It's just a component that I'm going to keep my business logic in, my MVC logic, rather. And it has to meet this contract in order to be a method reference in Java 8, naturally. So we say public all, okay. Do the same thing again for by ID and for the events. So mono server response by ID and events. Okay. So let's go ahead and implement this using our FluxFlix service, private final FluxFlix service. There's that. And what we're going to do is we're going to say server response.ok body passing in FluxFlix service.all. Okay? And we're going to say that the response is a collection of movies. So again, this is going to be JSON, right? So we have to tell Spring Webflux that it shouldn't try and use JSON, because JSON expects the whole JSON document, right? It shouldn't try and use traditional XML. We have to do message framing, because even if we're doing regular REST, values may be emitted, a minute later. They may be emitted whenever. So our processing, our JSON marshalling behind the scenes is smart enough to actually say, okay, this is one record at a time. We have a potentially unlimited amount of records. So it makes no sense to wait for all of them to appear. So we actually render the JSON one at a time whenever we can. So here's the all handler. Flux, we're going to say server response dot OK dot body equals flux service dot all, events, right, across the streams. And here we have to pass in the movie ID, right? So we're going to say string movie ID equals server request path variable movie ID. Pass this in, and do the same thing as before. Tell it that we have a collection of movie events. Now, again, remember what we talked about. This isn't a JSON endpoint anymore. We're expecting to send server-sent event payload. So we need to specify the content type here as well, just as we did before. Okay. So there's 2 out of 3, right? There's the events, and finally we have this one. Same kind of thing. We can just copy this code, put it here. Okay, and we can say server response dot OK dot body server flux service dot by ID, passing in the ID, telling it that's a collection of movies. And with that, we can now use this new route handler as a bean as a collaborating bean that we can reference here. So route handlers, and for our last method here, we can say route handlers all. Okay, let's create. We want to make this simpler, so I'm going to use. Let me do it in a second. I'm going to now chain these together. I'm going to create a new route that says I want to get the movies by movie ID, route handlers by ID, and chain it one more time. Request predicates dot get movies movie ID events, right? So same thing, route handlers events. Very good. So there's our functional reactive endpoints. And again, you can use static import, so let's get rid of that. You can get rid of the qualifier on the predicates there as well. So it becomes very clean at that point, and easy enough to read. So there is our rewritten code, and I think that's actually fairly approachable. If you like all your business logic, if you like all the mapping information in one place, this can be very useful as well, right? So let's try it out. There's all of our JSON, just as before. Let's grab this. Curl HTTP localhost 8080 /movies / this one / events. There we are. So we've got 2 different approaches to building our reactive web service. One is using proper REST and JSON. The other one's using service and events. But programmatically, and the way we interact with it, they're very similar, right? We don't have to worry too much about the differences. Now, it wouldn't be much of a service if we didn't build a client. So in our last waning minutes together, let's talk about building the client for our service. I'm not going to use MongoDB in this case. I'm just going to build a REST client that works with that data. So cd downloads unzip ffc.zip cd ffc idea pom.xml. Now what we want to do here is we want to make a call to the REST service. But again, from the perspective of a synchronous blocking REST client, nothing is different about what we've just done on the server side. If we have service end events and we've got a synchronous blocking client, that client's going to block. The server side is free to move the thread back into the thread pool during the idle times, during that 1 second gap, for example. But on the client, nothing is necessarily different. It can be, though, right? If you build your client to be smart enough to realize that certain things are asynchronous by default, then you have an opportunity to make more efficient the consumption of REST APIs from the client. And that's what we have here. We have the chance to do that as well. So let's look at the web client API that's new in Spring Web Flux. I'm going to start it on a different port. Okay, now we're going to create a bean. This is the alternative to the REST template, right? If you've ever used the REST template, then you know that the REST template is the workhorse of the sort of Spring MVC HTTP client world. But in the Spring Web Flux world, you have this web client, which is, it provides a reactive API. It provides the ability to not block when it's making requests on things that support asynchronous responses. So what we want to do now is we want to call our endpoint using the web client and just iterate through the values and then use that to get the service and event. And again, that's another thing that wasn't super easy to do in Spring MVC and the REST template. To call a service and event endpoint, the REST template by default would wait for all the responses to come. It wouldn't start churning them out when they're available. So let's say web client dot get dot URI HTTP localhost 8080/movies dot exchange and then subscribe. Let's just try that. Let's see what happens. What's going to happen is we're going to get, actually, for our subscription, we're going to get a object of type client response. And so our job is to take that client response and to tell the client how to turn that into something it can use. So I'm going to say, in this case, to frame the results, to frame the data that comes back as objects of type movie. And I don't have that type on the class path, right? So let's just cheat a little bit. I'll use these little empty entities here as DTOs on the client side. We don't need the mapping annotations for Spring data because that's not in play anymore. There we are. Okay. So I'm going to say, give me the body as a flux of movies, and then I'm going to say, just for now, let's see if that works. Make it wiggle. I'm going to say print out the results. Okay. So let's try this one. There we are. There's our records. Now that we know that that works, let's try using some of those operators we were talking about to find the result using a filter. So we're going to say movie.getTitle.equals ignore case, and let's grab a movie title here. Silence of the Lambdas. Okay. So let's try that. We should now have just one result. Okay, there you are. If you can see that, it's on the very bottom here, our one movie. Now what I want to do is I want to get the service and event stream and view that on the client. So here, we'll say silence. And here, I'm going to use the ID to make another client call. So client.get.uri HTTP localhost 8080/movies/ silence.getID events exchange.subscribe. And what I want to do here is take the client response from this, client response 2, and turn it into a body, or to a flux of movie events, and then print all that. So system out print line. Okay. And there we go. All the values are coming back as we expect. Because we're using these fluxes and these monos everywhere, it's pervasive. Our code, we can compose these. We can do higher order things with them. We can build systems that are optimized for asynchronous I/O. This gives us the ability to now think about things that aren't naturally what we would think about, things like WebSockets and things like service and events, in the same way that we'd think about anything. From the client perspective, there's no, we deal with it in the same way. We don't care that on the server side, it's actually just an array with 5 elements that got returned as a synchronous, blocking array list, because it's been wrapped in a flux. So we just have to know how to think about and work with publishers, basically, the Reactive Streams publisher API. What we looked at in this talk, in our little time together, we looked at Spring Webflux, we looked at Spring 5, the support for Reactor and Spring Webflux itself. We looked at functional reactive endpoints. We looked at the traditional Spring MVC style REST controllers. We looked at Spring Data and the Spring Data Mongo support, the reactive Spring Data Mongo support as well. And remember, this is very important. Reactivity doesn't make any sense if at any layer you have to block. You lose the benefits down layers. So it's important that the whole thing be non-blocking from the request all the way down to the data store and back, right? At any point in that, I don't have to wait for the reply if it's not there. This is important to us on the Spring team. So Spring Boot 2.0 will be due at the end of the year. One of the big features you'll see is that Spring Security will have support for reactivity, right? It makes sense, right? If you're doing reactive programming, you've got a reactive REST API. The last thing you want is to have to do a blocking check on a principal in a thread local, for example. That's not going to work anymore. Same thing for in Spring Cloud. Spring Cloud, we've integrated where appropriate the reactive APIs. And so in Spring Cloud, we have a new technology called Spring Cloud Gateway, which is very similar to Zool. It's a micro proxy. So you can use it to create proxies that talk to other services. It is end-to-end reactive, right? Using Spring Webflux, right? So we have a lot of interesting things happening here. This is just a preview. I hope you've appreciated it and saw some value or some opportunity here. I encourage you to kick the tires, to try the bits out. I'm happy to take questions if you've got them, though, and my time is up. So I want to thank you so much for coming. I appreciate it very much. Cheers.